All right, everybody, hello. Welcome to the MCAS review number 1. Today we're going to review one-dimensional motion or linear motion, Newton's laws of motion as well. So let's get started. So let's start with motion, right? So general motion, that's going to be about direction, how fast, what's their location of your object. And so when we're talking about motion, we have to take it from a frame of reference. And that is our relative motion. Okay, so our frame of reference can be different reference points. So when we're looking at a moving object, we have to take it from different reference points. So distance, that's going to be the length of the path between 2 points, and it's measured in meters. Displacement, now that's a description of the object's position relative to a given point. So basically it kind of goes back to like the length of a straight line from start to end. Speed, so that is the ratio of your distance over time. Okay, so like how fast or how long you are traveling over a given amount of time. Okay, so that's measured in meters per second. Okay, so we can talk about average speed, we can talk about instantaneous speed. So average speed, that would be like your speed over the entire trip. So let's go, like say you're going to the beach or whatever, and so you have to travel a certain amount of distance. How long did it take you to complete that entire trip? Where instantaneous speed would be like the speed at a particular point in time. So if you were to look down at your speedometer, that would be your instantaneous speed. So now we can talk about velocity. So that would be your average speed of an object in a specific direction. Okay, so again, it's still measured in meters per second because it's really like a displacement over time or a distance over time. So let's see how they're different. Okay, so remember when we're talking about scalars and vector quantities. Okay, so scalar quantities, they only have magnitude. So that means that speed is a scalar quantity. And a good example of that would be like Batman and Robin running at 5 meters per second, where a vector quantity has both magnitude and direction. So velocity is a good example of a vector quantity. And so when, again, using like the same example here, Batman and Robin, but they're running at 5 meters per second south or north, there's a direction involved there. So now let's go to this MCAS question. So an object is moving west at 30 kilometers per hour and another object is moving north at 30 kilometers per hour. Which of the following statements describes the motion of both objects? So go ahead, read through these examples, pick the best one that you think. All right, so I hope you picked C because C is the best answer choice for this. They have different velocities but the same speed. So remember that speed, that's your scalar quantity. It's going to describe the magnitude. So our magnitude in this case is going to be 30 kilometers per hour, but the direction is different. And so remember that velocities, they are a vector quantity. So because their direction is different, they have different velocities but the same speed. All right, so now let's talk about graphing velocity. So the way that we can see graphing of velocity would be with a distance versus time graph or a position versus time graph. So the slope of your position versus time graph is going to be your velocity or your speed. So we see different examples here with constant low speed, constant high speed, and varying speed. So with that constant low speed, you see that that slope is really, really short, right? It's not so steep. So that means that they're traveling not as much distance, but over a longer period of time. Constant high speed, well, that means that we're traveling a great distance over a shorter period of time. So we are like increasing that speed. Varying speed, that would be, sometimes you're going at that constant speed, then you're stopping, then you're going again. So we see that that slope of our distance versus time graph or our position versus time graph is going to read as our speed. All right, so let's talk about acceleration. So an object's change in speed or direction or both, that is going to be a change in acceleration, or your object is accelerating. And so the way that we measure acceleration would be in meters per second squared, meters per second squared. So your acceleration is your change in velocity over time. So remember that your change in velocity is your final velocity minus your initial velocity all over the time. Okay, so remember that your object can accelerate if it's changing speed, changing direction, or doing both of those things. So constant acceleration would be like a steady change in your velocity. So your velocity is changing at the same rate. Instantaneous acceleration would be a specific change in your velocity at a specific point. And deceleration would be like negative acceleration. So you're slowing down, but you're still either changing your speed or changing your direction or changing both. So let's look at this question. A car moves at a constant velocity for 4 seconds. A student records data on the car's motion as shown in the table below, but the student forgets to label the second column. So we are given an amount of time, and then we're given something. And so which of the following is the missing label? Go ahead and try to figure this one out. All right, so looking at this, constant velocity, okay, constant velocity. So that means that your direction and your speed aren't changing. So with that, when we're looking at what is missing here, the best answer choice is going to be distance, because if it was acceleration, well, that would be a change in your velocity. And there's no change in our velocity, it's constant. Force, again, if you change the force, that's going to change your velocity. It's going to change your speed. So force would not be the right answer here. In speed, well, we know that it's going at a constant velocity, so that's going to be a constant speed in a straight line. So that's not going to change either. So we see that, in that table, we see that that is changing. They're going from 30 to 60 to 90 to 120. So that is going to be distance. So as that time changes, we are going a certain distance over that time. Okay, so going back to graphing, when we are graphing acceleration on a position versus time graph or a distance versus time graph, the curve of this would show a change in velocity over time. So when you see something that is curved on a distance versus time graph, you need to recognize that that object is accelerating. It's not staying at a constant rate. It's actually increasing in speed. It's changing its velocity over time. Another way that we can show acceleration is with a speed over time or a velocity over time graph. And so when you see something like this, the slope of a speed versus time graph is your acceleration. So remember, you want to take that, the rise over the run, the change in the y over the change in the x in order to get the slope, and then you can solve for that acceleration of your object. So let's look at this MCAS question. So the velocity of a bus is represented in the graph below. So we're given the velocity over time here. So that change in speed, the speed over time. So we have our velocity, we're given some time. Which of the following best describes how the bus moves over time? Go ahead and try this question and do your best. So looking at this graph, the best choice is B. Okay, and the reason for that is because we have this speed that is staying constant, and we know that because the slope is 0, it's staying constant, it's not changing in direction at all. And then with that, at 20 seconds, we see that that slope is starting to increase. So that indicates to us an acceleration. There's a change in your velocity over time. And so with that, the best answer choice is B. So the second question, the graph represents how a motorcycle's position changes over time. So instead of the speed over time, we're now given position over time or a distance over time graph for a motorcycle. So which of the following graphs best represents the motorcycle's velocity over time? So we're looking at a position over time or a distance over time, and we need to now convert that into a speed over time or velocity over time. Go ahead and start working on this one. Okay, so the best answer choice here is D. The reason for that is because there is a constant change in your velocity, and it's a positive. It's not negative. So looking at A, we see that there is no change in speed there, so A would not be the right choice. B, we see that there is like some weird thing happening here where there's a curve and then a straight line and it stays the same, so that would not be the right choice either. And then we see for C that it's a negative speed or a negative change, or it's like decelerating. So in that case, C would not be the correct answer either, because if we look at our position versus time graph, we're increasing our position over time. And so with that, D would be the correct answer choice there. So the next question, the graph shows how the velocity of a car changes over time. So again, we're given velocity over time graph for a car, and we need to solve for the acceleration of that car. So remember back that we have to solve for the slope. So go ahead, try your best at solving for the slope and choose the best answer. Okay, so your answer should be 4 meters per second squared. So let's look at this. So remember that slope is your rise over your run. Okay, so your change in y over your change in x. So if we look at our little velocity over time graph, our change is happening from 0 to 4 on that y-axis and over 1 second. Okay, so our change in our rise would be 4 minus 0 over 1 minus 0. Okay, so we're going from, position of 0 meters per second to 4 meters per second, or I should say a speed of 0 meters per second to 4 meters per second. So with that, we have a 4 over 1. So your slope is 4, which means that on your velocity versus time graph, our slope is our acceleration. So our acceleration is 4 meters per second squared. So your answer should be B. Okay, so now let's start talking about force. So forces, a force is just a push or pull. And remember that forces are a vector quantity. They have both magnitude and direction, and forces are measured in newtons, and we represent that with a capital N. So a force is needed to change an object's state of motion. So with that, combining vectors. So remember that your vector is going to show your force direction and also that magnitude. So how long that vector is going to represent, the magnitude or how strong that force is. And so also it's going to show you the direction, right? So it's going to be pointed in a certain direction. That's going to show you the direction of the force being applied. So when those vectors are in parallel, you can either add or subtract them. So if they are in opposite directions, you want to subtract them. If they are in the same direction, then you're going to add them. So when we are doing this, we're actually solving for that net force. So remember that that net force is the combination of all of the forces acting on an object. Okay, so if we see something here that we see this driftwood that is being pulled by these two elephants, and we're seeing that that elephant on the right is applying 200 newtons to the right, and the other one is applying 200 newtons to the left. And so that net force is equal to 0 because we have this force acting in two opposite directions. So 200 minus 200, that's going to give us a net force or a combination of those forces as 0 newtons. So let's look at this MCAS question. So a student pushes a 12 Newton book to the right with a force of 10 newtons. The book experiences a frictional force of 3 newtons. The free body force diagram below represents the forces acting on the book. And we see that this free body diagram, we see this force acting to the right, 10 newtons. We have a frictional force, 3 newtons to the left. And then we have the weight and the normal force of our book itself. So 12 newtons up, 12 newtons down. So what is the magnitude of the net force acting on the book? So remember that this is the net force, the combination of our forces. So not only in the x direction, but also in the y. So in our y direction, 12 minus 12, that's going to be 0. So now let's just focus on the x direction. So we have 10 newtons to the right, which is going to be our positive side, minus 3 newtons because it's that opposite side. So your combination or your net force, go ahead and try to figure out the best option below. All right, and your answer should be A, 7 newtons. So now let's talk about mechanical equilibrium. So remember that mechanical equilibrium is a state where no physical changes occur, or when your net force is equal to 0. And so dynamic equilibrium would be when something is moving at a constant speed in a straight line and there's no net force acting on it. Okay, so your object isn't accelerating. So now let's talk about Newton's first law. So Newton's first law is also known as the law of inertia. So an object continues in a state of rest or a uniform speed in a straight line unless acted upon by a non-zero net force. So what this really means is that an object at rest is going to stay at rest, an object in motion is going to stay in motion until it is acted upon by a non-zero net force. That's going to make it change its motion. So the amount of inertia of an object depends on its mass, roughly the amount of material that is present in that object. So go ahead, take your best guess. Which one has more mass, 10 kilograms of gold or 10 kilograms of feathers? And your answer should be that they are the same. Okay, so mass is a constant, the amount of matter that is in material. So no matter where you are, that mass is going to stay the same. But weight is a force. It's a gravitational attraction to that object. Okay, so your weight would be your mass times the acceleration due to gravity wherever you are. So 3 rocks with masses of 1 kilogram, 5 kilograms, 10 kilograms fall from the same height. Which of the following describes the inertia of these rocks? Go ahead and take your best guess. Okay, your answer should be D. With more mass, you have more resistance to your change in motion. So D should be the correct answer there. All right, so now let's start talking about Newton's second law. All right, so Newton's second law is like F equals ma. Okay, so the acceleration produced by a net force on an object is directly proportional to the magnitude of that net force in the same direction as that net force and is inversely proportional to the mass of that object. Okay, so F, remember that is your combination of all of your forces, so your net force. So your net force is equal to your mass times your acceleration. And so the motion of that object is going to be in the direction of that net force, and it's going to be directly proportional to the magnitude of that force. So a larger force, larger acceleration. Smaller force, smaller acceleration. And inversely proportional to the mass of that object. Okay, so larger mass, smaller acceleration, larger mass, larger mass, smaller acceleration, smaller mass, larger acceleration. So Newton's second law applied to weight. So remember that weight is a force. We kind of represent it with Fw, all right? And it's your mass times g. And remember that g is the acceleration due to gravity. So no matter where you are, whether you're on Earth or whether you're on like the moon, your weight is going to change, but remember that your mass does not. So a 6 kilogram table has a net force of 15 newtons acting on it. What is the magnitude of the acceleration of the table? Go ahead and try this out. Give your best answer. Okay, so your answer should be B. So let's talk about it. So we are given the net force as 15 newtons, and we're also given the mass of 6 kilograms. So we have identified our knowns, and now let's solve for the acceleration, our unknown. Well, we write down Newton's second law, F is equal to ma, but we actually have to rearrange in order to get it. So we divide by mass on both sides, and that leaves us with acceleration is equal to your net force divided by your mass. Okay, so our net force was 15, our mass was 6, so we have 15 divided by 6, and that equals 2.5 meters per second squared, so your best choice is B. So let's review free fall. So free fall, it's the acceleration due to a change of speed of an object moving towards the Earth due to gravity. So with like skydivers, they're all accelerating towards the Earth at g. And what is g? Well, it's the acceleration due to gravity, and we call it 10 meters per second squared. It has an approximate value of that much. So objects falling near the surface of the Earth accelerate downwards at g, 10 meters per second squared. So when we're looking at this, objects move only by the influence of gravity when they're in free fall. So acceleration is your change in speed or your change in velocity over time. And so if we look at our table here where we have the elapsed time, so like how much time is passing, and then with that, what is that instantaneous speed at that time? So again, we're looking at like the speedometer, what speed you are at that certain amount of time. And so with that, at 0 elapsed time, we haven't changed our speed. At 1, 10 meters per second. At 2, 20 meters per second. At 3, 30 meters per second. So our change in speed is 10 meters per second over a time interval of 1 second. So that's how we get the acceleration due to gravity as 10 meters per second squared. And we also see that on the speed versus time table. So now let's talk about friction. So remember that friction is the force of friction between the surfaces, and it's going to depend on not only the kinds of material you're in contact with, but also like how much it's pressed together. So we talk about that as the normal force. The opposite of your weight. Okay, so remember that friction is always going to act in the opposite direction of your motion. So the diagram below represents two forces acting on a wagon being pulled to the left. The force applied to the wagon is labeled Fa, and the force of friction on the wagon is labeled F sub F. So we have our applied force going to the left. We have our frictional force going to the right, and that frictional force is 40 newtons. We can see this from the free body diagram. So if the net force acting on the wagon is 20 newtons to the left, what is the magnitude of the applied force? So remember, not only focus on the magnitude, but also the direction. So make sure that you get this one. Go ahead and try your best on this. Okay, so your answer should be C. So let's talk about it. So the first thing that I did was I assigned a positive and a negative side. So typically that right side is going to be the positive side, that left side is going to be the negative side. And we are told that the net force, or the combination of our forces, is 20 newtons to the left. So what that really means is negative 20 newtons. And we need to find out the applied force that is needed in order to get this net force of negative 20 newtons. So remember that F net, or this combination of your forces, is equal to your your combined forces, so the sum of your forces. So we have a positive frictional force in this case and a negative applied force. So it's going to be our frictional force minus our applied force in order to get our combination of those forces. But we know that we have to rearrange in order to get our applied force. So that's what I did. I subtracted this frictional force from both sides. And so we're left with a negative applied force is equal to your F net minus your frictional force. So then your applied force is equal to your negative net force plus your frictional force. So because our F net is a negative, that becomes a positive, and our frictional force gets added. So your force applied is 20 plus 40, so 60 newtons. And that makes sense because remember that our frictional forces, that is opposing that motion. But because we're still moving to the left, well, we have to have more force in that direction. So the applied force has to be 60 newtons in order for this net force to be 20 newtons to the left. So when we are talking about frictional forces, we can still have something that goes at a constant velocity. So when friction is present, an object may move with a constant velocity even when the outside force is applied to it. And that is because all of the forces can be balanced on that object so that there is no acceleration. So that normal force pointing up is equal to the weight acting down, and that applied force is equal to the frictional force. So with that object is just moving at a constant speed in a straight line, or what we like to call dynamic equilibrium. So with that, let's answer this MCAS question. So a box is moving at a constant velocity along a rough horizontal surface. An applied force opposes the frictional force as represented in the free body force diagram below. Okay, so we have that force applied, we have that frictional force opposing, we have the force of gravity and the normal force acting up. So which free body force diagram represents the forces acting on the object the moment after the applied force is removed, but while the box is still moving forward? So go ahead, take your best guess, and we'll go over it. Okay, so your answer should be A. So let's talk about it. So that normal force and the force of gravity are still going to be present on that object. Remember that weight acting down in that normal force, that's just keeping it on that surface. When it's still moving forward, don't get confused by this. That is a representation of your speed. It tells you nothing about the forces. Remember that it said that the force applied is being removed. It's just still moving forward. So with that, there has to be a force of friction at play, because remember that this force of friction is opposing your motion. So if your motion is still moving forward or to the right, as that applied force shows in the free body diagram initially, well, that means that your normal force, your force of gravity, and that frictional force are still going to be at play. So your acceleration, that should be your force normal, your force of gravity, your force of friction. That's because that object is still in motion. So last law, let's talk about Newton's third law. So Newton's third law states that when an object exerts a force on a second, the second object also exerts an equal and opposite force on the first. So for every action, there is an equal and opposite reaction. And the best example of this is a cannon and a cannonball. All right, so the force of the cannonball that is leaving the cannon itself is equal and opposite to the force that is recoiling the cannon. And that is it. I hope this was a nice review for you. If you have any questions, please feel free to reach out to your physics teacher. I'm sure that they will love to help you out, to help you prepare for MCAS. Bye, everybody.